Hello and welcome back to another segment of Terminating Low Voltage Cables. I'm Ron with Ideal, and again welcome to the channel. Hey, in this segment I'm going to talk about wire color code configurations for data circuits. Now if you're looking for one on phone, it's on the channel, so go check it out. But this one's for data circuits, and I want to briefly explain what pairs a computer actually uses typically within your home, and then I also will explain to you what the two wiring schemes in the industry are, which are 568A or 568B. So we're going to start by taking a close-up view of what a computer actually uses. So I'm going to switch to a close-up so you can get a good view of it. Here we're going to take a look at how computers actually hook up to the outlet in the room and what wires they actually end up using inside that cabling. And it's interesting that computers have gotten faster and faster and faster over time. And you know, when PCs first got developed, there was no way to make this PC talk to that PC. So we had to start coming up with means of communications between the devices. And there are a number of languages that have been developed over the years, but you should understand that one called Ethernet is one out. As a matter of fact, the internet uses Ethernet as a means of communications. And so when you look at this drawing here, you'll see underneath it some terms, and one says 10 base T, and underneath it says four-wire Ethernet. And when I see the term 10 base T, I know the guy's talking Ethernet because that's an Ethernet term. The T there stands for twisted pair cable, which is referring to catenary cabling. The base, which I won't get into, means baseband transmission, and the 10, the number, is an important thing to me because that indicates how much information can pass down the cable per second. In this case, it stands for 10 million bits per second, and to a computer, a bit is a 1 or a 0, and we obviously need a lot of 1s and 0s to make those things do what they do. And of course, the industry has 100 base T as well, which is 10 times faster than this. And we have 1,000 base T, which we call gigabit, which is going even faster. And we also have 10,000 megabit, which is 10 gig above that. And of course, the systems are getting faster and faster and faster. Now, I should indicate to you today that 10 megabits in a home, well, that's probably adequate. That's probably still above what your high-speed internet line might be. And in some cases, it's not. 100 megabits has really kind of become the minimum that I would suggest as far as a data network that you might want to install today. And that kind of future-proofs us for some period down the road. Now, in 10 and 100 base T computer networks, they actually don't use all the wires in the cable. They're only using 2 of the 4 pairs, and here's the pairs that are indicated. Pins 3 and 6 make a pair, and pins 1 and 2 make a pair. And essentially, one of them pairs is a transmit pair where we're sending information out to another device. The other pair is our receive pair that we're bringing information back from that device. So that's what the 2 pairs are for. Now, at 1,000 base, 10 and 100, that's true. At 1,000 base T, they start needing and utilizing all 8 wires on a cabling. And this is how come we really never tell you to mix phone and data on the same piece of category cabling. Because in your home, would it work? And the answer is yes, but if we ever jump to a minimum of 1,000, it's going to be a problem, and or you're going to have interference problems by mixing the 2 on a cabling. So if I'm doing a 10 base T data network in your home, and all I have is one Cat5 cable run to an outlet in a room, could I not take one of the pairs that's not being used in the cable, split that out away from this jack, I should say, and run over to a standard old phone jack and hook it up to it? And of course, with the wiring back in the other end here, back in the panel, that pair gets split out and run over to the phone board. And that supplies, again, phone to that outlet in that room. So now I got the 2 outlets wired through basically one category cabling. And would it work? And you know, the answer is yeah, it would. But we don't ever recommend it because, especially when the phone is ringing, there's going to be AC present down this telephone pair that's going to cause interference problems with the data circuits going down there. So you're not going to get 10 or 100 megabit speeds out of it. So you're going to always have interference problems. And you know, when Blockbuster Video goes away and all these other places, and we want to download all this stuff off the internet, we might be in the gigabit Ethernet speeds that you're beginning, that will get us into that, you know, needing to use all 8 wires in this cabling in order to do that. So be aware of the fact that you could, but we really don't ever recommend it to you. So that's the wires that a computer is actually using in most applications with 10 and 100 base systems. Next, we'll take a look at the actual wire schemes of the jacks themselves, what we refer to as 568A or 568B. Over here, we're going to take a look at the 568A and 568B wiring schemes. And the first one we'll look at here is the A sequence. A was the first one developed in the middle 80s. And a big thing happened in the middle 80s. A lot of things happened in the 80s, I guess. And one of those things that happened is that phone circuits got a lot smarter than they ever used to be. And some of us that are a little older, you remember back in the 70s and prior to that, you walk up to an office building and you'd walk up to a receptionist, and the receptionist would have a very large telephone system in front of them. And there would be wire going from that point to all the workstations in that office building, okay? And those telephone systems usually required 25 pair telephone wires to make those systems work. And again, if you remember the old phones, they're big, and they had all these buttons on them, usually kind of clear, sometimes red. And if the line was being used, that button would light up saying, hey, someone's using this line. And if I wanted to make an outside phone call, I'd have to pick up the phone, look for a button that wasn't lit up, and push the button which didn't get me a dial tone to an outside line, and then, of course, I could make a phone call. And we needed all these extra extensions for the building in order to make sure we had enough open phone lines that people could get an access to a phone line pretty readily. And so these phone systems changed a lot once we married computers to them. And once we mixed computers to those phone systems, they all of a sudden got a lot smarter. And you know what? We got to a point where we never needed no more than 2 pairs going to a workstation anymore. So the industry wanted to come up with a new jack design that could support phone or data, and we'd like to be able to support one or the other based on what we give the cabling back at an outlet in a room. So if I've got a Cat5 jack in a room, if I want phone, I can plug that into this cable into the phone board, and if I want data, I can plug it into the router or switch, and we don't have to go out here to the jack and rewire things. So the industry came up with 568A here in the middle of the 80s. And when you look at 568A and compared to old telephone wiring, and remember USOC, how that was wired, and again, check out the wire color code configurations for phone circuits, and you'll find that pairs 1 and 2 are in the exact same spots as they are in traditional phone jacks, okay? And that's how come this Cat5 jack can be used for phone. So if, again, I want to have a phone come into the outlet, I'll go to the other end of here and I'll plug it into the phone board and apply phones across pins 1 and 2 here. And now a customer at the outlet in the room can take his RJ11 4-conductor phone pluggy and snap it into this 8-wire jack, and it hits the 4 metal pins here, which is all I needed it to do. And I can use it for phone. Now, again, if I want data, well, the other end of this wire that's back in our panel will have to get hooked into a router or switch, but now it provides data. And as we said a minute ago, with 10 and 100 base T data networks, they're using pairs 2 and 3 here. Okay? So the jack could be used for phone or it could be used for data, and that's why we really like it for residential applications. As a matter of fact, the Resi application calls out wiring in A because we like that versatility. Now, there are a lot of people that don't like this concept of mixing phone and data, and they've got a really good reason for not wanting to mix the two, and that's the data guys. Because you can imagine when you look in an office building, traditionally we've had 2 different size connections. We had these little bitty ones, which are the phone only. We've had the bigger ones, which traditionally meant data. Could be phone, but most people think when they look at these big ones, they know that's a data line. The little ones, they know that's a phone wire. So you don't have any of the little ones no more. All you got are these. So I'm crawling underneath your desk, and I'm trying to find out where the high-speed internet line is for your computer. And I see a bunch of these jacks under there, but I don't know which one it is. So I just figure I'll get lucky here and plug it into one of these. So I plug your computer into that outlet. But that outlet underneath that desk is not the data one, it was the phone one accidentally. So now I plug your computer into a circuit that's getting phone, not data. Now again, a computer is trying to use pair 2 and 3 here. But in this case, line 2 is a phone line, not a data line. Well, the risk I run here is that when the phone rings, there's AC present on the telephone pair, which more than likely will fry the network interface card inside your PC or your device. So you can see how a lot of data guys are going, this is kind of stupid. Somebody in an office building is going to do this, and we prefer not to. And that's why you still see RJ11s in some of these office buildings, and we still got the RJ45, or the big ones for the computers, and that's how we decide which one's which. Now, so they didn't like this concept. So shortly after this was ratified, we pushed through what's called the 568B format. And almost all data guys wire in B. When they hear you're wiring in A, they're going to go, hey, Stooge, nobody wires in A. Why are you doing that? Well, they don't realize the Resi standards call it out, or again, a lot of government jobs would call out A too. So the B format got done, and when they pushed through B, the industry basically said, hey, listen guys, we're not going to let you change the physical size of this connection. We're not going to let you change the number of wires in it or the pairing or anything like this. The only thing they allowed them to do was change colors. So what's the difference? They flip pairs 2 and 3 in these two different sequences. Okay, so pairs 2 and 3 get flipped. So here it's green, but green's been moved here to the middle, and of course orange has been moved around as well. So the only difference is they flip the two colors. And when you look at a machine, you know, a computer is a pretty smart device, but is it smart enough to know what color the wire is that's utilized? And the answer is no, it doesn't. So when you look at the two here and you cover up the colors, and if you look just at the pairing itself, you would notice it's the same. I mean, there's a pair here. Now it's been flipped in what number it is, but 1 and 2 make a pair. 3 and 6 make another pair. 4 and 5 make a pair. 7 and 8 make a pair, and that's true as well over here. So to be truthful with you, there is really very little difference between A and B, and you can wire all the system in A, or you can wire it all in B, and I tell people to make a decision which way it is. But it can be done either way, because there is virtually no difference between the two, other than the fact that data guys have always wired in B. So that's the differences between A and B. And when you buy things like patch cords out there in the industry, you know, you might go down to a local retail environment and pick up a low voltage panel out of the set, and a lot of times those panels are wired in A. And in that same area, you'll find some patch cords being sold for the computers. Now, are these A or B rated? And the answer is, I don't know. Take a look at it. And more than likely, it'll be a B patch cords, because the people who make patch cords like this, they cater to data guys who are typically wiring B anyway. And if I don't know which way it's been wired, keep in mind this plugs into the jack here. Okay, so I pull that out of the outlet in the room, and I look at the colors down in here, and I look, you know, at the gold pins, and I see orange on the left. I know I've got a B patch cord in my hand. And if I look in here and I see green on the left, well, then it would be an A patch cord. Now, you're going to find that the B patch cords are probably all you're going to find. So say your panel's wired in A. Could you use a B patch cord? And the answer is absolutely, you sure can. Because the pairing is the same in both connections. The only difference is we've, again, flipped, you know, the two colors around. Again, the machine don't know what color the wire is. So yeah, you could use a B patch cord on an A system, and vice versa if that's what you want to do. So hopefully that cleared up some of the mysteries of 568A and 568B for you. And thanks for coming. I appreciate it. To another segment of terminating low voltage cables. And again, I'm Ron with Ideal, and we'll plan on seeing you the next time.